Hey, you're watching this because you want to know about box and whisker plots, and that's great. We're going to talk about box and whisker plots, what they are, and what the five number summary is, which is something that you need in order to make a box and whisker plot, and something you need to understand in order to read a box and whisker plot. Let's start off with this. This is a box and whisker plot. This right here is the box, and these are the whiskers. Um, Now, what this box and whisker plot shows is players' weights. These are players' weights in the NBA. Players' weights go from somewhere over 150 pounds. I think that would be 165 to as high over 300 pounds, maybe 310 pounds. How did I figure that out? I read the number line that's below this box and whisker plot. The number line's right here. Where something appears on this number line, or whenever something appears on this number line, a player, for instance, that's what his weight is. Now, how many players are recorded in this box and whisker plot? This box and whisker plot right here. The answer is we have no idea. If you didn't make a box and whisker plot, you're really only seeing five pieces of information. And I'm going to put them up. I'm going to highlight all of them right now. You're seeing the minimum value, which is the smallest given value for this set of data. So whoever this was, he was the lightest player in this data set. This person right here, the line, the kind of the left side of the box, he's the first quartile. We'll talk about what that means in a little bit. This line in the middle of the box, he's the median. So remember, the median is the middle number. So this is the person that was in the middle. He divided the set of players' weights. He's the guy who weighs more than 50% of the players in the league, but less than the other 50%. So he divides this entire set in half. This, the right side of the box, that line going up and down, that's the third quartile. And that line going up and down, that's the maximum. He's the heaviest player in the NBA, whoever he is now. So once again, there are five numbers we can see. Basically, all the lines that are up and down on this graph. I'll highlight them all right now. So there are five lines, five vertical lines here in the box and whisker plot. These are the five numbers that you need in order to make a box and whisker plot. We need the minimum, the first quartile, the median, the third quartile, and the maximum. So you need these five numbers whenever you have a set of data. If you can find these five numbers, you can make a box and whisker. I'm going to bring up a couple of sets of data, and we're going to practice, or I'm going to show you how to find the five number summary of those sets of data, and then we can use that later in a later video to make box and whisker plots and talk about what the box and whisker plot is showing us. So here's one set of numbers. They're just random numbers. They don't really mean anything. They're not connected to anything, but we can make a five number summary of this set of data. Let me put the titles of the five numbers that we need to find right below them. Okay, there they are. And now I'm going to give them a color so that I can highlight where they can be found on the set of numbers above them. Okay, so they're like tropical starbursts right now. Now I'm also going to start breaking this set down. First of all, let's count how many numbers are in our set. There are 14 numbers in our set. Now minimum will be the easiest one to find. It's going to be the very first number in my set after I put my set in order from smallest to biggest. That's already done here. So let's highlight the minimum. Okay, there he is. And now let's do the maximum. He's going to be easy to find too. He'll be the last number um, after my set is put in order from smallest to biggest. There we are. So we've got 2 out of 5 done. That's not bad. Um, Now our next step is to find the median. We can't find the first quartile and the third quartile until we found the median, um, for reasons that will become clear in a little bit. So let's find the median by crossing out from smallest going right and crossing out from the biggest going left until we meet in the middle, where there'll be one number or two numbers in the middle. So let me do that right now. Okay, so that's one set of crossing out. One more time. Getting closer. Alright, I can almost see it. Okay, almost there. Alright, we did it. There are two numbers in the middle. Two sixes, in fact. Let me circle them. When we have two numbers in the middle, we have to take the average of them and then divide them by 2. This will be pretty simple. They're both 6, so if we add them up and then divide by 2, our quotient, the result of that division, will be 6. Let me just write that above. And there's our median. Um, okay, so now that we've found the median, we can use that to find our first quartile. Our first quartile is going to be the median of this. What I just highlighted in yellow is the first half of our data. It was separated by the median, those two sixes in the middle. We're going to find the median of this set of data. We're going to do it the same way. We're going to cross out from the first number in this yellow half, going right. At the same time, we're going to cross out from the biggest number in this yellow first half, going left. And let me do that right now. Sorry, I should have included this first 6 in the median, since the median is actually the average of these two numbers in the middle. I should include this one too. Alright, let's cross out, continue to cross out. Okay, so we have found the median of this first half. And it's 4. That's the first quartile. It's half of the first half of the data, which is exactly 25%. Of is 25% of the 25% mark of your entire set, because half of 1/2 is 1/4 or 25%. So that's the first quartile. Let me highlight it. Okay, there we go. Okay, so let's move on to find the third quartile, and that's going to be half of the second half of the data. Let me highlight that in yellow right now. That's our second half. We're going to do what we did to find the first quartile. We're going to cross out from both sides until we reach the middle of this second half. Okay, so that's all done. The number in the middle of the second half is 8. That's the third quartile. I'm going to highlight it now. Okay, so we have our 5-number summary. Now what these numbers tell us is basically they give us an idea of where percentiles lie on our data set, where the smallest value is. That's the minimum value. They tell you where the biggest value is. That's the maximum value, right there. So the minimum value, there can't be a number in this set that's less than the minimum value by definition. So every number in our set has to be bigger than the minimum value, and no number can be bigger than our maximum value. Right here, by definition, everything has to be less than the maximum value. Now our median is right in the middle. Our median is right here. Half the numbers are going to be smaller than the median. Count them, there are 7 numbers in that yellow highlighted area, and half the numbers are going to be bigger than that 6 or equal to them. There's 7 numbers in that yellow highlighted space now. If we go back to the first half, the first quartile is going to be in the middle of the first half. He divides it in half, basically. There are going to be 3 numbers that are smaller than, there we are, and there are going to be 3 numbers that are bigger than him but smaller than the median, or equal. Now, what's important about the first quartile is that he is the 25% mark. 25% of the numbers are going to be here. So, roughly, if you put that into your calculator, 4 for the 4 numbers that are in this yellow box, divide that by 14, it should come out to roughly 25%. It won't be exact, but it should be roughly 25%. That is the definition of the first quartile. 25% of the numbers are equal to or lower than him. The median, everything to the left of the median, is half of the data set. There are 7 numbers in there. 7 divided by 14 is 50%. The median is 2 quartiles added together. So 50% of our numbers are to the left of the median now. Now, our third quartile, he'll be 75%. He'll be like the 75% mark. If a number is at the third quartile, it's bigger than 75% of the numbers in the data set. So if you divide this now, it should be 11 divided by 14. It'll be roughly 75%. Again, it won't be exact. Now, the maximum is, he's the highest percentile. If you're at the highest percentile, you are bigger than every number in your data set. The highest percentile is the 99th percentile. So if you ever see in a movie somebody's in the 99th percentile in anything, they're better than 99% of the people that we have a value for. So if they score in the 99th percentile on some test, they're really good. Maybe they can bend spoons with their mind or something like that. Okay, so I hope that it explains what the 5-number summary is. There's the minimum, the first quartile, the median, the third quartile, and the maximum. We find the minimum, it's the smallest number in our set when we put them in order, and the maximum is the biggest number. We find the median the same way we always do. To find the first quartile and the third quartile, we find the median of the 2 halves that our original median creates. I'm sorry, the median of each half of our data set. And once we have our 5-number summary, we can create a box and whisker plot like here. And we'll talk about why it's even useful to ever do this in another video. Okay.